Hi students, welcome to the next session of physics. Yesterday we discussed about some fundamental physical quantities, derived physical quantities, fundamental units, derived units, and some of the units we gave. So which are the base units or fundamental units, and which will be coming under derived units. Already we gave symbols and all this. So in that, so always we have to write units with small letters we said. But in your 10th class force unit you wrote I think Newton. Whenever you wrote Newton, you wrote capital letter, isn't it? Whenever you wrote second, you will write small s. When you have to write capital letter, when you have to write small letter. I think in yesterday's video I wrote I think Kelvin, I think small k. So Kelvin means it should be capital K. And ampere also I wrote capital A. So when you have to write capital letters means whenever scientist name is coming. So you don't know it might be scientist name or not, but whenever scientist name is coming, you have to write capital letter. Kelvin means scientist name. Therefore, so Kelvin you have to write capital K. Newton is scientist name. So already you came to know about Newton. You heard, therefore capital N. Second is not scientist name, therefore you have to write small s. Centimeter is not scientist name, you will write small letter cm. Okay, so while writing Newton, capital N we will write capital letter, but Newton means with small letter only we will write whenever we are mentioning units. So Newton will be coming in two ways, one is name wise, another one is unit wise. Whenever unit wise it is coming, we should write small letter. It should be starting with small letter. Newton. Force. 10 newtons. 10 newtons can be written as like this or like this. Again here we should not write capital N. Okay. So this is about when you have to use capital letter means capital letter, when you have to use small letter. Next we are measuring. So we are discussing about measuring of length. I told you parallax method. I told you all of you to see by closing your left eye, right eye. I think all of you might have done, I thought. So now we are discussing measuring of distances. Measuring of distances will be in two ways. One is large distances, another one is small distances. Where you will get large distance? Let us assume, so what is the distance from Earth to Sun? One planet to another planet. That is nothing but large distance. Small distance means small length of the chocolates. Still more small. So if a substance is made up of so many atoms and molecules, you can know size of the nucleus. So atom is consisting nucleus and electron is revolving around the nucleus, isn't it? So what is the size of the nucleus or atom? So all those will be coming under small size. So first I am giving ranges of lengths. Ranges of length. From where to where you can get length range? From 10 power minus 14 meters to 10 power 26 meters. What is this 10 power minus 14? How it will become? How we will write? So we will be coming to 1 by 10. 1 by 10 will be written as 10 power minus 1. Like that, 1 by 100. 1 by 10 square. This one can be written as 10 power minus 2. So 10 power minus 2 value, if you want to use 0.01, this is 0.1. Which is small? This is small. 10 power minus 2 means 0.01. 10 power minus 1 means 0.1. 10 power minus 3 means 0.001. Isn't it? So 1 decimal place, 2 decimal place, 3 decimal place. Like that, 10 power minus 14 means 0.0000, almost 14 decimal places we are going to get. This is small value, bigger value. This is small value. Whenever minus is there, that is small value. You should remember. So 0.00, 14, 13 zeros and 1 1. Therefore, total you will be getting 14. So 10 power minus 1, 1 decimal place. 10 power minus 2, 2 decimal place. Next year, 10 power 26. This is for our convenience because we are not able to write all this 0.000001. Therefore, they will represent like this. Next, 10 power 26. This is positive value. Positive value means 10 power 1. 10. 10 square. 100, 10 cube, 1000. So this is bigger value, like that 10 power 26. So almost you will be getting after one 26 zeros. That even bigger value you will be getting. So we can't read simply, therefore for our convenience we are going to write like this. This is range of the length. Means minimum length is 10 power minus 14. Maximum we can take up to 10 power 26 meters. They have given that one in one tabular column. You can see once. This is ranges of it. Whenever we are getting, we will say centimeter. Centimeter means in meters we will say, like meter. Meter means 100 centimeters we will write. Like millimeters also we can write. Isn't it? Same like that. How we will write these values and how we will call the 10 power minus 15 is there. How we will call means this. 1 Fermi. We will write like this. Fm is equal to 10 power minus 15 meters. So 10 power minus 3. How we will write? 10 power minus 3. This one we will write millimeter. Isn't it? 10 power minus 3 meters means 1 millimeter can be written as 10 power minus. Same like that. 1 Fermi, 1 FM can be written as 10 power minus 15 meters. Next, this one you might have heard or not, I don't know, in your 10th class. This is size of the nucleus, there you will be getting. Next one I think definitely you might have heard. Angstrom. Have you heard angstrom? So 1 angstrom. So 1 angstrom we will write like this. A power 0, like this way. So 1 AE, 1 angstrom is equal. How much you will get? 10 power minus 10 meters. That is Fermi and angstrom. Next one, 1 astronomical unit, 1 AU, 1 astronomical unit. So 1 astronomical unit, 1 AU, 1.496 into 10 power minus 14, 10 power minus 11 meters. What is astronomical unit definition? The average distance. Sorry, not minus, this is plus. Because this is a big distance, large distance. 10 power 11. So the average distance between sun from the earth. The average distance between sun from the earth can be called as astronomical unit. This is also distance. I am saying meter. This is small distance. 10 power minus 15, 10 power minus 10 is very small distance. This is little bit large, plus 11. So distance between sun and earth is very big. 1.496 into 10 power 11 meters. Next one. 1 light year. 1 light year means 1 LY. L refers light, Y refers. So what is light year? 9.46 into 10 power 15 meters. All these are bigger values. Therefore you will get plus. Just how to remember minus plus I will say at the end. So large values means positive you will be getting. Otherwise you will get confused. Minus you will get. Okay. So 1 light year means the distance traveled by the light in 1 year. So light will cover some amount of distance in 1 year. 1 year means 365 days. So how much distance it is traveling, that is called light year. Will it travel more distance or less distance? So it will travel more distance. If you forgot this value also, how to remember means we came to know velocity of the light is equal to distance by time. Then distance equal to velocity into time. Velocity of light you came to know 3 into 10 power 8 meter per second. Time means 365 days. 365 days means you should convert into seconds. 365 days. 1 day 24 hours. 24 into 16 to 60. So 3.3 into 10 power 8. This is velocity of light. Time 365 days. So some average. Leap year is coming means some average it is going to be changed. 365.2 something will be coming. 10 power 8. 365 day. 1 day 24 hours. Hour means 60 minutes. 50 seconds. If you multiply this value means you will be getting this value. So light year means the distance traveled by the light in 1 year. Astronomical unit means the average distance from sun, average distance of sun from the earth. So this is light year value or positive year because more distances, 10 power 15, here 10 power 11. These are bigger values. Next one. So all these are ranges of length. Now all these will be coming under fundamental or derived. All these will be coming under fundamental. Next one. So this is plus 11, not minus 11. This is plus 15. Nothing is there means that is nothing but plus 1 parsecond. So parsecond in this it is the second. Therefore some people will think that is unit of time. That is not unit of time. That is the unit of distance. 1 parsecond. The average radius 3.08 into 10 power 16. 3.08 into 10 power 16 meters. What is the definition means? The average radius of the Earth's orbit. Average radius of the Earth's orbit. Subtends. Subtends means some angle is going to make. So this angle. That angle is nothing but 1 arcsecond. The average. This is the distance. Parsecond is the distance of average radius of the Earth. Subtends an angle of 1 parsecond is called parsecond. 3.08 into 10 power 16 meters. So that is the definition of parsecond. So Fermi, angstrom, astronomical unit, light year, parsecond. All are the measurements of length. I am saying repeatedly why because next parsecond will be coming under which unit they will ask. So that it will be coming under fundamental unit. So next one. So now among all these, so which is having more length? Large distance, small distance. Large distance means which is having plus symbols, those are large distances. Which are having minus symbol, those are nothing. Minus symbol means powers. Those will be nothing but small distances. I gave here for you how to get idea on minus 10 powers, 10 power plus. Okay. So now we are going to measure large distances by using parallax method. Yesterday means I told you to see 2 points. So the distance between those 2 points we call it as basis. What is the basis means? Between distance between your 2 eyes. Once if you have seen this tip of the chalk piece with left eye, next time right eye, then it will be having 2 positions. Isn't it? I think already you did that now. So parallax method. Parallax method is used to measure large distances. How we will see means if you want to find planet distance from here we are going to see. So this is one planet, let us assume. So at one point we have seen this is A. So on Earth we are there. So we move to B some distance. This distance we came to know. Again we have seen. Okay. So this angle is theta. Okay. This is the distance. How much distance we moved from A to B? Let us assume small b. Then we came to know theta definition. In this previous video also we gave generally you came to know. So B by arc length by radius. Then D is equal to B by theta. So this value you will be coming from. This capital D is nothing but distance of this planet from the surface of the Earth. How we will measure large distances means by using this method. So an angular size. Angular size means if you want to find what is the diameter of the Earth. Earth is nothing but big, huge planet. At the time, how will you get an angular size? They will say this one will say alpha. This B is going to become diameter of that. Means Earth will be like this. We will see 2 points from large distance, isn't it? So this is A, B. Then distance we have to find. Alpha is equal to diameter by this distance. Okay, so this is angular size of the Earth also we can say by using this form. Okay. So next one is measurement of small distance. So measurement of small distance means I told you already 10 power minus 8 meters to 10 power minus 10 meters. So two microscopes will be there. Optical microscope and electron microscope. Optical microscope, in the name only it is there. In optical microscope, we are going to measure the range of visible light. What is the range of visible light? 4000 angstrom to 7000 angstroms. Angstrom means 10 power minus 10 meters. Already we gave that one. So this range we are going to measure by using optical microscope. Still more less particles are. That is nothing but electron, proton, neutron. So that size is very small. So that one we are going to use by electron microscope. This is almost range of 0.6 angstroms. Electron microscope is used to measure very small particles, subparticles of the atom. Like that they may ask me one more question. Okay, so this is optical microscope. Optical means this is word used for light. Therefore, visible light length, that is nothing but wavelength. Wavelength is also distance. Okay, optical microscope is used to measure wavelength range of this much. That is nothing but visible light. So electron microscope is used to measure very small distances like subparticles. Okay, so this is about measuring of small distances. Next one, they gave some problem example 2.1. Calculate the angle of 1 degree, 1 minute, 1 second. Use 360 degrees is equal to 2 pi. So they gave one problem. Use 360 degrees is equal to 2 pi. 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. This is very simple one. If you know time clock very well, then what is 1 degree value, 1 minute value we will give. Okay. So 1 minute we will say. 1 minute means whenever the seconds needle is going to rotate, one complete rotation. That is called 1 minute. Only one oscillation. That is nothing but one oscillation means just like this it is going to move. At that time we are going to say 1 second. So that one is going to complete 60 times. Then we are going to say 1 hour. Okay. That one they gave conversion here. Calculate the angle of 1 degree. So 1 degree means they gave here 360 degrees equal to 2 pi. So who will be having textbook? So you can see that is example 2.1. Calculate the angle of 1 degree. So value of 1 degree there are. 360 degrees equal to 2 pi. 360 degrees equal to 2 pi means 1 degree is equal. 1 degree means this 360 is going to this side. 2 pi by 360. That is nothing but 1 degree is nothing but pi by 180. This pi value 3.14. If you solve this one, you will get 3.14, 3.12 or 22 by 7 you can take. 3.14 by 180. So this value is the 1 degree value. Or simply you can remember pi by 180 units radians. So 1 degree is equal to pi by 180 radians. This is the 1 degree value. Next, 1 minute value. How we will get 1 minute? So 1 degree equal to how many minutes we said? 60 minutes. Isn't it? So like 1 hour. 1 hour is equal to 60 minutes. Like that. 1 degree is equal to 60 minutes we are saying. 60 minutes means. Now 1 degree value how much you got? Pi by 1. 1 degree is equal to pi by 1. 1 degree equal to how many minutes? Minute symbol they will write like this. 1 degree equal to 60 minutes equal to pi by 180. I am saying for rotation. Okay. Now here 1 minute is equal. 60 minutes equal to pi by 180. Then 1 minute is equal to pi by 180 into 60. 360 degree equal to 2 pi. Then 1 degree this 360 came this side like that. 60 minutes equal to pi by 180. Then 1 minute is equal to pi by 180. This 60 is coming here. If you solve this one, you will be getting 1 minute value in terms of radians. Okay. Next, 1 minute is nothing but 60 seconds. Isn't it? Next 1 second value there also. 1 minute. 1 second value there also. So 1 minute is equal to 60 seconds. 60 seconds how you will write? Here one line you gave means that is called minutes. 2 lines you gave means that is called seconds. Okay. So 1 minute is equal to 60 seconds. That is nothing but pi by 180 into 60. Therefore 1 second is equal. pi by 180 into 60 into 60 radians. Already these values they gave in textbook. Just if you type here 3.14 by this value, you will be getting that. I am not giving that value. Whenever there we are asking, we will do like this. 1 degree is equal to pi by 180. 1 minute is equal to pi by 180 into 60. So very simply means whenever they are asking me, first remember this value. 1 degree equal to pi by 180. Later you can remember 1 degree 60 minutes, 1 second. Sorry, 1 minute 60 seconds. So that is example 2.1. They gave values here, so I can give value there. And example 2.3, 2.4 you can only solve by using that equation what we gave. Example 2.2, the tan 40 value should come to know. Tan 40 value you should come to know how to see the logarithms. Logarithm book if there means, so we will learn. We have to learn that logarithm how to see. Otherwise tan 40 value you don't know. Okay, so that one we will do later after knowing logarithm book. Next, they gave the concept of measurement of mass. Okay, so measurement of mass. Generally, how we will say mass means this mass is nothing but how much matter contained in the body. We will say 1 kg. Generally, whenever we are using in our normal usage kg, gram, we will say like that. So 1 kg of gas. 1 kg oil, 1 kg sugar, we will say. So can we say 1 kg of gas? Okay. So gas molecules we are going to measure in terms of amount of substance. That is nothing but moles we say. And still more subatomic particles will be there. Electron mass, proton mass, neutron mass, like this. Generally, so I think you might have had atomic mass unit. Atomic mass unit. AMU you might have. What is atomic mass unit? This is simply they will write one small u. One u they wrote means that is atomic mass unit. So this is used to measure small particles like electron, proton, neutron. So what is the definition of this one? 1 by 12th of 1 by 12th of mass of carbon 12 isotope. Carbon 12 isotope. 1 by 12th mass of carbon 12 isotope mass is having how much? That value is nothing but 1 atomic mass. That value is nothing but 1.67 or 66 into 10 power minus 27 kg. So very important value. We should come to know this value for 1 mole. They will ask what is one atomic mass unit, either definition or value. So how we will differentiate means by using mass spectroscope. By using mass spectroscope, so we are going to measure some atomic particles, and in gross ratio of some weighing machine will be there. So that one by using generally to measure the mass, you can know physical balance they will say. So all these are the how to measure mass, and large masses will be there. Planet mass. I want to measure what is the mass of the Earth. Means that one we are going to get in lesson gravitation. So Newton gravitational method will be there to measure the mass of the planets, large mass. This is for very small value. 10 power minus 27 means very small value. The small value we are going to measure by using mass spectroscope. So in gross ratio of whatever we are using, that is physical values. Okay. So large masses we are going to measure by using gravitational method. Newton gravitational method will be there. That one will be coming in our gravitation lesson. So there we will see. So this is nothing but different masses and how to measure different masses of the objects. So next range of masses, range of distances we got. Fermi like that, from where to where like that, range of mass. 10 power to 36 kg. 10 power minus 14. So minus 14 or minus 15 will be there. Sorry, mass na 55. 10 power minus 30 to 10 power 55 kg means universe. Universe mass is almost this much, 10 power 55 kg. Minimum mass, subparticles masses like this 10 power minus 30 onwards, it will be coming. This is a range of the masses from where to where. Distance means 10 power minus 14 to 10 power 26 meters. Mass means 10 power minus 30 to 10 power 55. Next one is measurement of time. They gave measurement of time, atomic standard time. So we are going to measure vibrations of the cesium 130. How many vibrations means 9, 192, 637, 440. 9, 192, 631, 631, 770. So these many vibrations in cesium 133 atom. We are calling it as 1 second. So this is not that much important. Just we are giving, I told you already, mass kg definition, second definition, and current ampere definition, Kelvin definition. All those are not required for you. Just they gave how many vibrations in 1 second in cesium 133 atom. So in chemistry you will be coming to know. So ground level to next high level. These vibrations will be moving from one state to another state in cesium 133 atom. So this is the measurement of time. Atomic standard time, this one we will say atomic clock or cesium clock in our measurement of time. So these clocks we are not going to use here presently. So they will use, you will say in any mobile if you bought means time, Delhi, New Delhi, yeah, IST, they will say Indian Standard Time. So there you can see this one, but not that much important for us. Next one is very, very important topic for us, accuracy, precision, and error. Accuracy, precision, and error of the instruments whenever we are going to measure, or apparatus they will say. What is apparatus means? Scale. Scale is an apparatus to measure the length. So what is accurate value? What is precision value? More precise value. Precise value. Precise or precision. Whenever we are calling this one precision we will say. So whenever we got accurate value or precise value means how is the difference we will say, and what is error. Let us listen. We are measuring length of this chalk piece. So this length of the chalk piece is, let us assume, originally 5 centimeters. True value. True value, let us assume 5.53 centimeters. Just can assume 5.53 centimeters. Whenever we are measuring with scale, length of this chalk piece, you got length of the chalk piece is nothing but 5.4. So 5.4. Another one got, let us assume 5.3 centimeters. You use another different scale. Now, which is accurate value among these two? Generally, with our common sense, we can say 5.4 is accurate value, isn't it? How we are saying? I am going to give accuracy definition. Just I am giving example. 5.3 is there, 5.4 is there, but true value is 5.53. Therefore, which is close to the true value? That value is nothing but accurate value. Okay, that is only definition. So the measured value is how close to the true value. That is called accuracy. Understood? So measured value is how close to the true value. So that is called accuracy. That is only definition. How close to the true value with measured value is called accuracy. Next, precision. This is very, very important. So precision is going to depending on resolution or limit of the given apparatus or given instrument. So what is the resolution word or limit? We will see first. So one scale is there, and I didn't say the definition because first you have to understand this. What is resolution or limit of the apparatus? This is a scale. Initially, this is 0, 1, 2, 3. This scale resolution is nothing but, so minimum we are going to measure by using the scale 1 centimeter. Minimum value is only 1 centimeter. Another scale is there. I think this scale you can see. This is 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is 1. Next. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is 2. 1, 2, 3, 4, 5. 1, 2, 3, 4. This is 3. So by using this, what is the minimum value you can measure? That is nothing but only this. This is the minimum value. That is nothing but 1 millimeter. Otherwise 0.1 centimeter. How you will get means 1 by 10 centimeter. Isn't it? 1 millimeter is the minimum value for this. For this 1 centimeter minimum value. Another scale also you can see. That one is, this is 0. That is it. 1, 2, 3. So 0, this is 1. Then this one is going to become 0.5. This is 1. 1.5. This is 2. 2.5. Like that up to 0.5, 0.1. 0.25, like that it will be okay. So see this now. This is going to minimum is 0.5. Here minimum is 0.1. So this is minimum is 1 centimeter. This is called a resolution of the scale. So by using this, we are going to get minimum 1 centimeter. By using this, minimum we are going to get 1 millimeter. By using this, minimum we are going to get 0.5 mm. Minimum. How to get one? That one means very simple. This is 1 by 1. How many divisions between 0 and 1? 1. 1 by 1. That is nothing but. Here between how many divisions are there? 0 to 1, 10 divisions. Therefore, 1 by 10. That is nothing but 0.1 centimeter. Between these two. Here. 0, 1, 2, 3, 4, 5. 1, 0, 1, 2, 3, 4. So between 0 and 1, how many divisions are there? Means 20 divisions. So 1 by 20. So this is nothing but resolution of the scale. By using which scale we are going to get more precision value means by using this one. If you use this one, you can't get more precision value. You may get accurate value, but you don't want to get more precision value. So this is nothing but up to what limit or resolution you are going to measure the value. That is nothing but precision. How close to the true value? That is called accuracy. Up to what limit you are going to measure? That is called precision. So this is only chalk piece. I am going to measure chalk piece length. I kept like this. Up to here. Okay. Now this one you came to know. This is 2 you came to know. How we will assume this value? Let us assume this is exactly in between 1 and 5. Therefore, length of the chalk piece by this scale is 1.5 centimeters. This 0.5 you assume, isn't it? Exact value came to know 1, but this is in between 1 and 2. Therefore, you wrote 1.5 centimeters. Repeat, I am saying once again this 0.5 we assume because here no value is there. Same chalk piece you brought onto this. Okay, so whenever you brought like this. Now this is there in between. This is 1.5. This is next value is 1.6. Now it is there in between 1.5 and 1.56. Isn't it? This is 1.6. This is 1.5. In between 1.5 and 1.6 is there. Therefore, you wrote by using this 1.55. 1.5 is exact value. But this 5 we wrote extra y because we don't know in between exactly 1.5 and 1.6 it is there. At center it is there. Therefore, we assume this value. For this value also name is there. That one only we are saying it as error. Okay. So simply I am not writing here. What I am writing, that one only we are going to say it as error. And for that one separate name will be there. Okay. Up to here one more is there na. So if you extend this one like this, 1, 2, 3, 4, 5. 1, 2. This is 1. In between, this is 2. In between 0 and 1, 20 divisions. In between 1 and 2, 20. Same chalk piece I kept here. So here we got 1.5, here we got 1.55, here you will get exact. Length is equal to 1.5. This one is 55. 1.555. In between 1.5 and 1.6 it is there. I wrote like this. This one also assumed value. Okay. If you understood these two, that is enough. This is not required. So some scales will be like this. Once you can draw and write, draw the diagram, you will be getting exactly. And this assumed value. We are assuming this one. I think I understood well here. So here between 1 and 2. Here in between 1.5 and 1.6. That one we wrote it as 1.55. So among all these, which one is more precision value means this one. Okay. So which scale is more, up to what resolution we are going to measure means, so minimum value is going to depend. So up to what minimum value we are going to find. So that one only precision we are saying. So they gave the example. Let us assume 5.4 we got. This is true value. 5.4 is accurate value. Next, one girl found 1.43. One girl found 1.345. Among these two, which is accurate value means 5.43 is the accurate value because this is close to this one. 5.345 up to 3 divisions we got here. Therefore, this is most precise value or precision value. Understood the difference? Accurate value and precision value. Value may be accurate, but more precision is different. Accurate value is different. Up to what limit you are going to measure. And this one another definition will be coming for you. Least count. So what is the least count definition means? The minimum value measured by the any instrument. Here normal scale. So this is resolved up to 1 centimeter. This is resolved up to 0.1 centimeter. This is resolved up to 0.5 centimeter. Let us assume. Then 1 centimeter we are going to measure. So least count of this scale is 1 centimeter. Least count of this scale is 0.1 centimeter. That is nothing but 1 by 10. So 0.1 centimeter. Okay, so this is nothing but least value. The least value measured or the minimum value measured by the instrument or apparatus is called least count, we will say. We are going to find least count of vernier calipers, screw gauge, speedometer in our lab. But normal scale least count is this one, the minimum value which is going to measure. Next, I am going to do definition for error. So what is meant by error? Here we get. So exact value we came to know 1, we don't know. We are getting between 1 and 2, therefore we wrote this value, we assumed 1.5. This rounded value is called uncertainty. The uncertainty in the measurement is called error. Therefore, after measuring with this scale, we got 1.5. Then you got error. Some 0.05 is the error you got. So, the uncertainty in the measurement is called error. So, those errors will be coming because of different reasons. So, next our topic is that one only. So, types of errors, systematic errors and random errors. We are going to discuss that one. Now our next topic, errors, types of errors. Now you have to understand what is accurate value, precision value, what is meant by error. Accurate is nothing but the measured value is how close to the true value. How we will get true value, we will see. Okay, so the measured value is how close to the true value. That is called accuracy. Precision means up to what limit or resolution we are going to find the measurement or by using any measuring instrument. Let us say best example is scale. You will be coming to know. So in your you will be having in your compass box or geometry box, scale will be there. See once the scale between 0 and 1 10 divisions are there. Between 0 and 1 20 divisions are. So once you can check, then you will be getting which is the minimum value. Minimum value is here 1 by 20. Here 1 by 10. Here only 1 because 0 and 1 only 1 division is there. Okay. So that is nothing but precision. Error means the uncertainty. Uncertainty means the assumed value. Here this 0.5 we assume. Why? Because it is between 1 and 2. Here we assume between 1.5 and 1.6 it is there. Therefore 1.55. This one we assume. Therefore which one we are going to assume? The That value is nothing but the uncertainty is nothing but error. So we got like let us assume we are measuring length of the chart. We got up to here. Up to here means we will assume this one either 2.1 or 2.2, isn't it? So 2.1 or 2.2 we will assume. The 0.1 is nothing but uncertainty in the measurement. Okay. Next we will see types of errors. So next types of errors. So what is error? We said already. The uncertainty in the measurement is called error. So types of errors: systematic errors, and random errors. So the errors which are coming in either one direction, systematic error, either in positive direction or negative direction. Those errors will be coming under systematic errors. That may be because of instrumental errors. Instrument means which one? Scale we are going to take. Because of scale, fault, you will be getting error. How it will be coming, we will see just with example. Next, experiment. Whenever we are doing experiment, by unknowingly or knowingly, we will come up with some errors. Next one is personal. Personal errors entirely it is depending on us. We will take some carelessness while taking or measuring readings. Those errors will be coming under personal errors. Random errors means which will be coming irregularly in sign and size. Irregularly it will be coming because of surrounding changes, atmosphere, pressure, temperature all will be changing because of that one human. Instrumental error. Systematic errors will be coming under because of instrument. Instrument means whenever we are using scale, in our lab we are going to use wood scale. At the time, initially 0 will be. So this 0, by using, it is going to be erased. 0 you can't see. Then we are measuring length from starting. Then starting is already rubber and error. Then always you will be getting 0.1 or 1 millimeter length less you will get. Why you will get less means because one reading already erased. Erased means like this. So this is 0. 1, 2, 3, 4, 5. 1, 2, 3, 4. This is 1. So this 0 is going to be erased. Whoever using, they will get this 1 mm error whenever they are going to find. Length of the chalk piece. Let us assume 1 centimeter. But actually it is not 1. This is only 0.9 centimeter. Why? Because this one is going to be erased. So imperfection in instrument. Because of imperfection in instrument, we are going to get error. Next, experimental errors. While doing experiment, you will be getting errors because of setup and all these. Experimental setup, if you do wrong means you will get experimental errors. Next one is personal errors. Personal errors is entirely depending on us. We will take carelessness. We are not caring properly means because of our carelessness, you will get personal errors. So you will be getting exactly 1.5. You didn't see properly. So if you are seeing from below, this will be seems to be 1.6. If you see from above, it seems to be 1.4. Exactly, your face and eye should be at same level. So that will be coming under personal errors. So entirely depending on us. So because of our carelessness, this type of errors will be coming. Okay. So even if you do error also, that will be coming under physics. But we won't give marks for that. Error is nothing but error. So under different types of errors we discussed how these errors in the percentage error, relative error, absolute error, all these different names will be there. So we will see that one in our next class. Now up to now we discussed more theory you may think. So only 2 classes. From tomorrow onwards we will get again equations and problems. Okay, in this house. Therefore be ready for that one. Okay.